to apply data science to something that you're passionate about. For me, that was surfing. Hey everyone, my name is Matthias, and this project will show you the best time to shoot some curls. Let's start off with my surf stats. I lived most of my life in El Salvador, and I'm a proud Florida State graduate. Let's go Knowles. My stance is goofy. My tallest wave has been around 4 meters or 13 feet. I am a very big board guy and enjoy surfing, skating, and snowboarding. And here are my career stats. As you can see, I've been to 2 tournaments and my best place has been 4th. Let's return to the project and take a look at the goal. Have you ever been at a beautiful beach but can't decide what time to grab brunch at because you're not sure at what time your surf session is going to be at? How are you going to know when the biggest waves will be? As a surfer, you can imagine you want to ride the biggest waves since those are always the funnest. The goal of the project is to create a simple tool that can predict when waves will be at their highest. To get started, let's take a look at the data. The data comes from the National Oceanic and Atmospheric Administration, also known as NOAA. It originally included over 1 billion entries and 75 columns, making it 60 gigs of data. Massive data cleaning had to be done in order to get it into a workable size. This is an example of some key features that were used in the final model. Now let's move on to some key visualizations. Here we see a wave height distribution plot. As you can see, there are clearly more smaller waves than bigger ones, most being between 0.5 and 2.5 meters. This means that most of our predictions are going to be on the smaller side. Now that we've seen our wave count, let's take a look at some key features. Here I have plotted my target, or what I am predicting, which is wave height, against our most important feature, which is wind speed. You can clearly see a positive correlation between these 2 variables, meaning that whenever wind speed increases, so will wave height. Moving on to our next area of interest, here's a visual representation of my project's workflow. The data was originally hosted on Google's BigQuery cloud service. I connected it to it using an API and had to use SQL queries in order to import the data locally. Massive data cleaning had to be done in order to get the data in a workable state, both by deleting missing data, eliminating collinear features, and removing plain inaccurate data. A random forest model was chosen that will make predictions of future wave heights using these key variables. And my model will predict when biggest waves will be, which in turn gives us our best time to go surfing at. Now onto the most important part. How well did my model actually predict? My model is able to predict wave height with an average error of around 0.5 meters. As I mentioned, the biggest waves would be the funnest, and 1.5 feet of difference would never ruin a surfer's day. To finish this off, let's move on to where I'd like to take this project next. As for next steps, I would love to take this online, either as an app or a Flask app. This is a mock-up of what a Flask app would look like based on my model and how the recommender would work. As you can see, you would input your location and it would output a prediction of the next 12 hours and highlight the highest waves, which in turn would be the best time to go surfing. Overall, the most rewarding part of the project was learning to work with such a large data set and get them into a workable state. I would now like to take some questions about this project.